See a Tesla supercharger and wonder, can my car plug in here? The short answer is maybe, but not for the reasons you think. This video is for CCS EV owners who keep spotting Tesla stalls and asking whether an adapter is all you need. I'll walk you step by step through the real requirements, the physical adapter, the vehicle software, and the behind the scenes authorization that actually lets charging start. No marketing fluff, just the things that make or break your next supercharger stop, with exact examples and numbers you can use today. Hello, I'm Shayan, an engineer specialized in electric vehicle development. Why this is confusing? NACS swept into the industry fast. Automakers and charging networks are shifting towards it. Tesla already opened parts of its network, and media headlines make it sound dead simple. But plug fit isn't equal to plug working. The connector shape changing is the easy part. The invisible bits, how the charger and car talk, whether the Tesla's network recognizes your VIN, and whether your OEM pushed an OTA update, are the trickier parts that actually decide whether the power flows. Tesla's own page says select superchargers are open to non-Tesla cars that are NACS equipped or have a compatible adapter, and to check access before you plan a stop. Physically, NACS is a different plug than CCS, but deeper down, there are two differences that matter: communication protocol and authorization. CCS and NACS charge stations use a digital handshake to authorize a session. That handshake involves the car, the charger, and a backend user or account. Even if the plug physically fits through an adapter, the charger needs to accept the vehicle's VIN and the vehicle needs to support the software stack. Regarding backend and billing, Tesla superchargers are tied into the Tesla's billing and authentication systems. For non-Tesla cars to use superchargers, Tesla needs a way to identify the vehicle and bill it, often via Tesla's own backend or an approved external integration. That's why adapter alone is a myth. What's required to charge? To actually get kilowatt into the battery at the Tesla NACS station, you commonly need 4 moving pieces to be present and in the correct state. A CCS equipped vehicle, your car, a DC rated CCS to NACS adapter that supports the charger's voltage and current. Not all adapters are equal. AC adapters only work for AC home charging, not DC fast charging. Vehicle software that supports charging via NACS or an OEM-approved adapter workflow. This is an OTA or software issue. The car's ECU must know how to negotiate charging when an adapter is used. Tesla backend or VIN authorization or a compatible billing path. The charger checks the vehicle identity and whether charging is allowed. Without the network recognizing your vehicle or VIN, you won't get authorization. Missing any one of these equals to charge either fails or is limited. Tesla's official pages and OEM rollout info make the authorization step very clear. Physical fit alone doesn't guarantee access. Not all adapters are created equal. Here's the quick owner's translation. AC-only adapters let you plug into Tesla destination chargers or home AC ports with the NACS plug. These are fine for AC charging, typically up to 7 to 22 kilowatts depending on your car and supply. They will not work at Tesla DC superchargers. DC fast charging adapters. The special CCS to NACS adapters designed to enable supercharger use. These are rated for high voltage and high current and include the right signaling and interlocks. Some OEMs are distributing official adapters like Hyundai, Honda, so the adapter plus software plus the backend combo works reliably. Reports show Tesla's adapter-capable superchargers can deliver significant power, but some sessions have been limited by software or site capability. Published examples mention up to 250 kW in some scenarios, but actual rates vary. Cheap, unapproved adapters are dangerous. They may not have that required interlock safety or thermal ratings. Manufacturer support is being rolled out by brand and sometimes by VIN number. Some brands are shipping new cars with NACS ports built in, so no adapters are needed. Others are issuing OEM-approved adapters as a temporary bridge. Access often depends on an OTA update to the vehicle to support the adapter handshake and the necessary communications. Some OEMs also require VIN registration or backend linking so Tesla's network will accept the vehicle. Hyundai, Honda, Porsche, and others have announced adapter programs or NACS port plans, but timelines and specifications differ by model and region. Consequence: same model can behave differently across model years or software versions. Always check your OEM guidance before assuming a supercharger will work. How charging actually starts. The handshake in plain words. Here's what happens when things go right. You attach the CCS to NACS adapter to the supercharger handle. Some networks require adapter attached before connecting. Plug the adapter into your car's CCS inlet. The charger and vehicle begin a communication handshake. They exchange identity, safety status, and required control signals. The charger calls its backend, which may be Tesla's system, and confirm the VIN or authorization and payment path. The charger and car negotiate power, voltage and current, and safety interlocks, then the current flows. If any step fails, for instance, the backend doesn't recognize the VIN or your car software doesn't speak the expected protocol, charging will not start. Tesla's support pages and OEM guides show that the authorization step is a gate you can't bypass by a cable alone. Payment and app flow. Who charges the card? Different flows exist right now. Tesla's app plus Tesla billing. Many early non-Tesla access programs require the Tesla app to start and build charging sessions because Tesla's backend handles payment and session management. Honda and Acura adapter rollout initially uses Tesla's app and backend to initiate sessions. That's changing as OEMs integrate their apps, but for now plan to have the Tesla app ready. OEM app integration. Some brands will route billing through the OEM app or integrate plug and charge ISO 15118 so you can simply plug and go. Plug and charge rollout is progressing across networks and OEMs, but it's not universal yet. Don't assume the charger's sticker rating equals your session speed. Factors that change actual power. Charger rating versus site capabilities. A charger might be capable of 350 kW, but the site's grid feed or the charger's load management might limit the power. Vehicle pack temperature. A cold battery triggers lower initial power until preconditioning warms it. Studies and OEM guides show preconditioning helps you hit high plateaus more often. State of charge. Batteries charge fastest in the mid-state of charge window. The last 10 to 20% always tapers. 400 volt versus 800 volt architecture. Your vehicle voltage architecture affects peak power and how it negotiates with the charger. Adapter capability and software limits. Even with a heavy adapter, your car or the charger can limit power for safety. Reports show some early adapter sessions saw reduced peak kilowatt due to software or site limitations. Cold batteries charge slowly. Preconditioning the battery en route to charge usually vastly improves peak and sustained power when you plug in. OEMs and research show preconditioning raises pack temperature to the ideal window and can shave minutes off a fast charge stop, especially in sub-freezing conditions. Use the navigation to charger function in your car when available to trigger preconditioning. Common charging failures, what to watch. If your session fails, these are the most common culprits. Unsupported vehicle or missing VIN registration with a charger backend. Wrong adapter type. Trying an AC adapter at a DC supercharger will not work. Outdated vehicle software, missing OTA or adapter support. Station not enabled for non-Tesla vehicles yet. Not all superchargers are live for non-Tesla access. Connector not fully latched or dirty or wet pins. Physical issues cause the safety shutdowns. If a charge session fails, try resetting the adapter and connector. Check your OEM app and Tesla app for messages, and move to another stall if possible. The best practices for owners, quick checklists. Use only manufacturers approved adapters where possible. They include the right safety and signaling. Keep your vehicle software updated. Many access problems are fixed with OTA updates. Navigate to the charger to precondition the battery for better speed, especially in cold weather. Have the Tesla app installed if your OEM notes is required for the initial session. Don't use cheap third-party adapters for DC fast charging. They may lack interlocks and thermal protections. The future is cleaner and simpler. Automakers are adding NACS ports natively. Networks are adapting plug and charge ISO 15118, and backend integrations will let OEMs apps or plug and charge handle the authentication without any problem. Over time, Adapters will be temporary bridge, and many cars will charge at superchargers natively or through standardized plug-and-charge flows. But for the next couple of years, expect a mixed landscape and plan accordingly. What to do at the station right now? If you need a fast top-up today and you see a Tesla supercharger, check OEM guidance, search your make or model for official NACS adapter support, and whether a specific VIN list or OTA is required. If your OEM offers an adapter program like Hyundai, Honda, or Porsche, follow their instruction and carry the official adapter. Have the Tesla app downloaded and your payment method set up if your OEM requires it temporarily. Navigate to the charger to trigger preconditioning. Attach the adapter as your OEM or Tesla advises. If it fails, try another stall or contact OEM support before trying third-party hacks. Adapters are a powerful bridge to more chargers, but the plug is just step one. Vehicle software, VIN backend, authorization, and the right adapter type are the real keys. If you prepare by checking OEM guidance, keeping software updated, and using official adapters and Tesla app when recommended, you'll unlock many more charging options without surprises. If you want to learn more about the battery management system inside the electric vehicles and how do they calculate different characteristics of the battery pack like state of health or state of charge, you can click on the link in the description. Thank you.